Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to go over graphing or graphing transform trig functions. So last time we looked at the graph of the sine, the cosine, the tan, the cotan, the secant, and the cosecant. And let's just review quickly at least the sine curve. So we know that sine 0 is 0, sine pi over 2 is 1, sine pi is 0 again, sine 3 pi over 2 is -1, and sine 2 pi is 0. So basically, you have a center line at 0, and then you have a graph that looks something like that. Now, if I continue, we'll start a new cycle. So we call the distance between two consecutive points in two consecutive cycles the period. And the period of the sine or the cosine is 2 pi. For the tan and the cotan is only pi. But here it's 2 pi. Also, we see that the height here is 1, whether you take it from center line to minimum or from center line to maximum. We call that the amplitude. So the amplitude, oops, is 1. The period is 2 pi. What can happen to a sine or any trig function? It can move sideways, like an x displacement or an x translation. We refer to that, the x translation. We call it as the phase shift. That term would be very important in science and engineering. You will learn it. Then, of course, I can move the whole graph up or down. That would be a y shift. Well, I said x translation is x shift, but we don't say usually x shift, we say phase shift. And there is the y shift. The graph can be stretched or shrunk in both directions. So there is an x shrinking or dilation and y dilation like any graph. And of course, you can reflect it by, if you have a negative x, then it would reflect about the y. If you have a negative y, it would reflect over the x-axis. So basically, that's it. And the method I'm going to use, I know that you have an equation that tells you y equals a plus a times bx plus c and then plus d, and they refer to each letter with something, but I don't want you to memorize. I want you to go back to what we did before. In fact, I have a worksheet here that has 8 problems. So I've picked one sine, one cosine, one tan, and one secant. Okay. Hopefully we'll have time to finish all of those. And I will show you how by using the same exact method we had before, we can plot these. So the first equation, number 1, it says y equals 3 sine theta minus 5 pi over 6. Notice I'm not going to say what is the length of the period, what is the shift. No, I'm not going to do any of that. I'm going to say, well, the parent function is y equals sine theta. So I only have the sine on the right. There is a 3. So I'm going to divide by 3 both sides. That's it. Now, I know x and y for the sine. We just wrote them down. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And these are 0, 1, 0, -1, 0. We know that. And now we are coming here to say, well, what did we do or what should we do to make this thing theta? Okay, so for theta, I simply need to add 5 pi over 6, and that is a phase shift of 5 pi over 6. to the right? Because I have to add. For f of x or for y, I simply multiply by 3. That's stretching by a factor of 3. So now I can create my function table very easily. The y, we add 5 pi over 6. So 5 pi over 6. 5 pi over 6, and this is 3 pi over 6. You get 8 pi over 6 or 4 pi over 3. You add 5 pi over 6, and this is 6 over 6. You get 11 pi over 6. You add 5 pi over 6. This is 9 pi over 6. So 5 plus 9 is 14 over 6, which is 7 pi over 3. I just don't want to waste your time. You can use a calculator and add the fractions. 2 pi is 12 over 6. 5 is 5 over 6. You get 17, excuse me, pi over 6. That's it. What did we do for the y? We simply multiplied by 3. So the 0, 3, 0, negative 3, 0. You see how fast it is? And now we are going to plot it. So I have a center line at 0 because there was no vertical shift. I have an upper limit, or the maximum is at 3 and the minimum is at negative 3. When did we start? We start at 5 pi over 6. So this is 5 pi over 6, and we finished one cycle at 17 pi over 6. In the middle, it was 11 pi over 6. Oops, I wrote pi 11. 11 pi over 6. Here it's 4 pi over 3. And here it's 7 pi over 3. Notice that we didn't do anything to the sine except moving it right to left, so the period is still 2 pi. Notice also that if you subtract 5 from 17, you get 12 pi over 6, which is 2 pi. Notice also that we didn't have to multiply the theta or divide it by anything, so we didn't squeeze or shrink or stretch the theta by any value, so it stays 2 pi. Now the amplitude, we multiply this by 3, so the amplitude became 3. There is no phase shift, and there is no vertical shift. So really, if you want to draw it, you start at 5 pi over 6 at 0, go up to 3, go down to 0, go down to negative 3, and then up back to 0. And that would be the answer. Okay? Nice. Let's take number 4. This is a cosine. And you notice the cosine is, you just start here, a phase of pi over 2. So we are going to, if you want to draw the cosine, it's identical except that we move the graph pi over 2 to the right. The shift of negative pi over 2. So that's pi over 2, and that's, so if you say this is basically 0, this is pi over 2 on this scale, and this is 3 pi over 2, and that's 2 pi. Still the period is 2 pi, still the amplitude is 1. Nothing changes except that the shape of the curve is like this ball or something. Okay, so let's go back to our graph. It says y equals cos theta over 4 plus pi over 2, over 4, I'm sorry, minus 2. Again, I'm going to add 2 to both sides. And now my original graph that only has cosine on the right-hand side, and this one also has cosine on the right-hand side. If I want to do the x and y quickly, I get 0, 1, pi over 2, 0, pi, negative 1, 3, pi over 2, 0, and 2 pi 1. That's basically the parent function. Now, what did we do here? What did we do for theta? Of course, everybody, and it's correct, by the way, don't misunderstand me. Say, I'm going to subtract pi over 4. That's a negative phase shift pi over 4 to the left. And then I'm going to multiply by 4, which means what? Stretching x by 4. What happens when you stretch the x? Yes, your period would be multiplied by 4. So instead of 2 pi, you will get 8 pi. Even if you don't see it here, it doesn't matter. Don't worry about it. Okay? I want to draw your attention to something else. Don't try that at school. But do you see this equation? I could have written it as cosine and then take 1/4 out and make that as theta plus pi and say, no, I'm not going to subtract pi over 4. I'm going to subtract pi and then multiply the rest by 4. You will get the same exact answer since your math is correct. Notice I cannot take the 1/4 outside because it's not linear. Cosine of 1/4 something doesn't equal 1/4 of cosine something. Be careful. But I can take it out here and look at it from different perspectives, and both are correct. However, that may cause you trouble in the test or the homework, so just do it the way you learn. For y, oh, for y, subtract 2, meaning there is a shift of 2 units down. Now, let's translate that mathematically and see how easy it is. What did we do to our function? We subtracted pi over 4 and then we multiplied by 4. So when I subtract pi over 4, I get negative pi over 4. Multiply by 4, I get negative pi. Subtract pi over 4, I get pi over 4. Oh, I'm sorry. Yeah, so multiply by 4, you get positive pi. So you see, we add 2 pi every time. And that makes sense because we are going to add 2 pi, so I get the 8 pi. So in fact, you don't need to worry and keep doing the math. You know for sure this is 3 pi, this is 5 pi, and this is 7 pi. If you are not sure, keep doing it. So you say pi, I'm going to subtract pi over 4, so it's 3 pi over 4, multiply by 4, it's 3 pi. For the y, you just subtract 2, so -1, -2, -3, -2, -1. And here is my graph. I start at negative pi, and then I have a pi, I have 3 pi, I have 5 pi, I have 7 pi. This center line, which is next to the 0, is -2. I go up to -1, and I go down to -3. And again, at negative pi, I am at -1, meaning the maximum. And then I will go down like that, up like that. Of course, not to scale, so it looks horrible. But I just didn't want to waste time doing that. I just want you to get the idea quickly because we really, I don't want it to be very long session. Okay, let's move to the third one. It's the tan. If we want to draw the tan function, remember the tan, negative pi over 2, 0, pi over 2, and this is negative pi over 4, and pi over 4. I know at tan 0 is 0, tan pi over 4 is 1, and it's going something like that. Tan negative pi over 4 is -1, And this goes something like that. And then this repeats. So it starts from here and one from here, but that's basically what we are looking for. Okay. So we don't have like an amplitude. We have a center line that can change, and we have a period of pi that may change. Also a phase shift. But of course, since you go to infinity and negative infinity, there is no y shift. So let's try to do it here. Y equals tan 2 theta minus 11. Ugh, every time it's 11, I write the pi first because the way we write 11 is like what you when you write pi. Again, all what I do here is to add 1 to both sides. Here is my tan of theta, the parent function. I can say at negative pi over 2, it's negative infinity. At negative pi over 4, it's negative 1. At 0, 0. Pi over 4, it's 1. And pi over 2, it's infinity. Now, what did we do for theta? I have to add 11 pi over 6, right? I have to add that. So add 11 pi over 6, that's the phase shift. Then I have to divide by 2, shrink by 2. So the period is pi over 2, not pi, right? For y, subtract 1, meaning move 1 unit down. Here is my table for my function. I'm going to add 11 pi over 6 and then divide by 2. This is negative 3 over 6. So when you add 8, you get, I'm sorry, you add 11, you get 8 pi over 6, which is 4 pi over 3. You divide by 2, you get 2 pi over 3. Negative pi over 4. When negative pi over 4 is negative 3 over 12, and this is 22 over 12, so you get 19 over 12. 19 pi over 12. That's horrible. Oh, we didn't divide by 2. So over 24. Does that make sense? Let me see again. So we said 11 minus 3 is 8. We divided by 2. We get 4 over 6, which is 2/3. Here, we added 11 and we added 22 and we subtracted 3. So it's 19 over 12, and then you divide by 2. Okay, how about this? You add 11 over 6 and divide by 2, so it's 11 pi over 12. Yeah, so we're adding, every time we are adding 3 over 12, right, a quarter. So here, pi over 4, which is 3 over 12, and 22 over 12 is 25 over 12, so you get 25 pi over 24. And finally, pi over 2, which is 3 over 6. You add 11, you get 14 over 6, which is 7/3, and then you divide by 2, you get 7 pi over 3. Wait a second, I think we didn't, not we. Let me check the numbers. I'm going to say 2/3. No, I'm going to say negative 1/2 plus 11 over 6 divided by 2. It's 2/3. Yeah. Okay. Negative 1/4 plus 11/6 over 2. Let's multiply by 24. It's 19. Okay. This is easy. It's 11 pi over 6 divided by 2. And this one is 1/4. Let me put it between parentheses. 1/4 plus 11 over 6 divided by 2 times 24. Yeah, it's 25 over 4. And 1/2 plus 11 over 6 over 2 multiply by, oh, that's not correct. That's what I was worried about. This is only 7 over 6, not over 3. Okay, so you can see the period is this minus that. This is 4 pi over 6, and this is 7 pi over 6. So 7 minus 4 is 3 pi over 6, which is pi over 2. So my period is pi over 2. How about the y? The amplitude is the same, but there is a y shift of 1 going down. So you subtract 1. This would remain negative infinity, and that would remain infinity. This would be negative 2, negative 1, 0. And now we can draw like 5 lines. This line is negative 1. Okay, and then we say at 2 pi, this is 2 pi over 3, 19 pi over 24, 11 pi over 12, 25 pi over 24, and 7 pi over 6. Here it's negative infinity. Here it's negative 2. Here it's 0. Here it's 0. 0. So we did a period of just want to see that. Let me go to mode. I am in degrees, so let me change that into radians. And then say tan of 2x minus 11 pi over 6 minus 1. Now let's go to, okay, let's trace. Okay, it doesn't want to stop because probably I gave, okay. So we want 2 pi over 3, so what is that? This point, I think we need to go to the next one. No, this is more than a pi. What? Hmm. Let me get, oops, let me get, oh yeah, that's what I want. A value. I'm gonna enter for x, for example, 11 pi over 12. No, I did something wrong. This is, yeah, this is correct. Minus 1. Did we do something wrong here? We added 11 pi over 6 and divided by 2. 10, 2x. Oh, no. No, but it's not a big deal. I have an extra parentheses, but it's not wrong. The window, I want it to be from, like, let's say half a pi, like pi over 2, up to, like, 3 pi over 2. But now, if I go to calc and I say, give me the value of y when x is 19 pi over 24. It's -2, so this is correct. Why it was wrong last time? How about x is 11 pi over 12? -1. I don't know. For some reason I thought I did some mistake. No, it's correct. Sorry for wasting your time. It should be correct if your math is right, but for some reason I probably clicked the wrong button. I don't know which one. Okay. Last one, number 8. It says 3 secant theta over 2 minus 3 pi over 4. Again, you can see, like in the previous problem, I could have factored the 2 out and made that theta minus 11 over 12 pi, and it would have been the same thing. Same thing here. I could take 1/4 as a common denominator, and that would be 2 theta, or I took 1/2, and this would be theta minus 3/2 pi between parentheses. There is no addition or subtraction. Okay, that's why. So all what I have to do here is to divide by 3 both sides. Again, my parent function is y equals secant theta. If I have x is 0, y is 1. X, should we do pi over 6 and pi over 4 and stuff, or just pi over 2? Pi over 2 goes to positive infinity. And then at pi, I get -1. And then at 3 pi over 2, I get negative infinity. And then at 2 pi, I get 1 again. So what did we do here? For theta, which is x, I have to add 3 pi over 4. That's the phase shift. Then I have to multiply by 2. That's stretching x by a factor of 2. For the y, I just stretch by a factor of 3. So how does that show up here? I add 3 pi over 4 and then multiply by 2, it becomes 3 pi over 2. Add 3 pi over 4, meaning that would be 5 pi over 4 times 2 is 5 pi over 2. Notice I always add pi, right? So this would be 7 pi over 2. This would be 9 pi over 2, and that would be 11 pi over 2. Just adding 2 pi over 2. And sure enough, the difference is 4 pi. Why? Because the original was 2 pi, and I stretched it by 2, so it became 4 pi. Period is 4 pi. Phase shift is 3 pi over 4. Amplitude is 3. So now, remember I told you how we are going to plot the original function? But here I go to, oh, we didn't stretch by 3. So 3, infinity, negative 3, negative infinity, 3. Okay. So the center line here, and I have this is 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and 11 pi over 2. Alrighty, I started at 3. So let's say this is 3, and this is negative 3. Notice there was no vertical shift. At 3 pi over 2, I am here, and then I go up to positive infinity. And then at 7 pi over 3, I am at negative 3, and basically this goes something like that. And then this goes something like that. Of course, if we had made like something in the middle, you would have seen why we are doing that. Uh, but you can see that it's going down here and up there. And this would continue. So this cycle would repeat forever. And that's it. That's how you graph, how you easily graph without memorizing what does A stand for, B and C and D and all these complications. Okay, finally, I wanted to go over these things, and really that won't take any time. Find the transformations required to obtain the graph starting with a basic trig function. So what did we do here? First of all, I'm going to divide by 5, and then I'm going to say phase shift of negative 5 pi over 6 because I want to subtract. And then I'm going to multiply the y by 5. Amplitude becomes 5. What did I do here? And here, that's where I said I can take a factor out the 8, and that would be 3 pi over 32, but they will tell you, no, 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 you did it wrong. So I subtract 5 to make that a sign. First of all, I have a phase shift of negative 3 pi over 4. Then my shrinking of shrink x or theta by a factor of 8. Notice if you shrink by 8 and it was 2 pi, meaning now the period would be pi over 4 because you divided by 8. And then also you had a vertical shift of positive 5. You have to add it to make it y. What happens here? I add 2 to both sides. So I have a phase shift of pi over 6, and then a vertical shift of negative 2. Why? Because it's y plus 2. How do I make it y? I subtract 2. Here, 10 times. Phase shift of pi over 3 to add, nothing else. Y is 10y, so I have to divide by 10, meaning uh, the amplitude becomes 1/10. Uh, Here we have a problem because the amplitude, I mean, we don't have an amplitude for y. Y goes from negative infinity to plus infinity, so it would stay the same. But the point where the 10 goes to 1, like at pi over 4, it would be 1/10. Okay, so there is, instead of saying that, we'll say vertical shrink by a factor of 10. That doesn't affect the infinities, right? So you divide by 10, it's still infinity or negative infinity. I hope this wasn't bad that you learned about it. I was saying this is the last session, and then I realized we haven't yet done the law of sines and the law of cosine. So I think I will I'll see how long it would be. Should we do that on a 1 or 2 sessions? And I started long time ago to upload 2 videos per day. So by the time we finish, you will have ample time to review and solve back exams. Thank you very much for watching. Wish you all the best. If you have any question, as usual, don't hesitate to comment, and I will try to get back to you as soon as I can. Thank you very much. Have a great day.